and welcome. Thank you for popping in. If you are new to the channel, please give a like and subscribe. Hit the notification bell if this content is helpful for you, and you will be notified of the next video release. In my previous video, I talked about a very beginner level explanation as to what DevOps is. If you are very beginner, watch the video popping up in the top right corner of your screen before you watch this one, as it is a reduced explanation, an easier to digest explanation for those that might not be comfortable with all of the different terms, software development lifecycle and whatnot. So with that out of the way, I wanted to give a more thorough explanation as to what DevOps is and the steps and tools involved with DevOps. So what is DevOps really? In my beginner example, I described DevOps as the cornerstone of development and IT. And really what we're talking about from a business standpoint is we are talking about development, writing software, and operations. And in the past, these two things were very much separate. The developers wrote code. When they were done with it, they would, build it and hand it to the operations people who were in charge of putting it on a server and running it and making it available to customers, clients, whoever we made the application for. So DevOps is sort of the next generation of the agile methodology. And really what is focusing on trying to do is bringing the development and operations teams together, right? And we want to do that because when you think about those two separate places in your organization, you could see why this would be beneficial. Imagine developers writing some software, they hand it to the operations team to get it running, and the operations team tries to take it and they put it on the server and it doesn't work. And so they go back to the development team and they say, "What's up?" And the development team responds with, "You guessed it. Well, it worked on my machine." So that's where tools like Docker come into play, right? And so before I get into the tools, let me give you the life cycle of a typical development operations project and go over kind of each piece. So we have discover, plan, build, test, monitor, operate, and continuous feedback. So discover. What is discovery? Well, if you're familiar with writing applications, you know that this means requirements gathering. We meet with stakeholders, we meet with users, and we nail down what is it that this is supposed to do. And in very clear language, right? This should take X data and give you back Y data after performing some calculation. Or, this should perform some sort of workflow, whatever it is. Plan. Well, what does planning look like? Well, planning would be like the wireframing. We put together, what does this look like? What is a workflow for a user, a person, a customer using this software? Build. Build is pretty straightforward. We write the software, right? You have to write the code that creates the application that you're delivering. And then test. Test means writing tests. We write our unit tests, integrations tests. There's lots of testing involved, but that's what test is. Monitor, and we would want to monitor server and app performance. Operate. This is incident change and problems tracking, and then continuous feedback. Now, there's many tools that can cover some of one of these. Some tools cover more than one of these, but I'm going to talk about some of the ones that that I've used in my projects and that our company uses. And I'm not going to go into what company I work for, but we work with some big enterprises. So for our requirements gathering, we use a combination of Google Workspace, and we also use Slack. You will find in my explanation that we keep coming back to a few, and that is because there's no need to add additional applications if there are ones available that work nicely, that increase collaboration and reduce cognitive load. And for those that are not aware of what cognitive load is, It is the requirement of a person to learn a tool in order to be productive. So for that reason, our company strives to reduce the amount of applications an employee needs to learn in order to be productive in their workload. So the discover phase requirements gathering, we use Google Workspace, and Slack. This is where we collaborate on what our requirements are. This is where everybody knows to go and look. And this is Slack. We also communicate regularly using Slack. Plan, the wireframing. So there's, again, a few different ones that you can look. But what we want to do here is we want to break down an application, a piece of software, into smaller, manageable chunks. And so we would create wireframes that are available on Slack. We create them usually using Adobe XD. Shoutouts to Adobe, not being paid to say that. And we make them available in a Slack channel. So every time a Adobe XD wireframe gets posted, everyone that needs to know that that exists will get a notification saying, hey, there's a new wireframe here, check it out. The wireframes allow comments, and we all collaborate on giving our 2 cents for each frame. So that brings us to build. There are, and when I say build, write software is certainly involved, but once we get the software written, we also need to build the application. And so from a DevOps standpoint, this becomes critical because, as I joked earlier, the old, well, it worked on my machine. And from a DevOps perspective, where this problem needs to be overcome is with things like Kubernetes and Docker, right? If you never want to hear that phrase again, you need to implement either Kubernetes or Docker. We use Docker, and we use it extensively. One of the last applications that we handed over had 5 different packages, and each package had a Docker container involved with it. I'm going to do a video on Docker because it is so powerful, but for now, write software and use container, some sort of container. In the past, it was virtual machines were the way to go. Unfortunately, well, fortunately for end users, virtual machines use tons of resources because they're pretending to be a computer from the hardware level up. Kubernetes is a little bit further up than that. It fakes a little bit less than a VM, but more than Docker. And then Docker is the lightest weight, super easy to use, very powerful, very fast. But you do have to be operating system specific, right? So that's Docker's downfall. And I say downfall, but really Docker's the best. I mean, you have to have your containers set up for the type of machine that they need to run on, right? You can't have a Docker image running, a Docker image built for a Windows machine running on a Mac. But I feel like the trade-off is way worth it because of how much they improve your life. You know that every piece of software required to run an application will be inside of that, and you won't have to worry about it, right? It's all inside the container. You fire up the container, and you're good to go. So that's the build, and I wanted to go off on that one for a while because it's super important. So then we have test, and tests, you know, there's all kinds of testing tools out there, but there's X-Ray, Mabel, Zephyr Scale, SNCC, Mend, there's all kinds of them out there, but I would focus probably on like the automated testing, and that's what these things are for. I should have been writing these in there as I was doing this. So tests, automated testing, Veracode, StackHawk. I'll put Veracode in there. Veracode, and these are tools to help with automating your testing. We don't want to be having to manually run tests every time. I will also point out that I will also point out that there are, there's front-end testing libraries like Jest, and we would implement those using like a pre-commit hook like Husky. So we would probably, in our latest application, we used Husky to fire off a pre-commit hook. For those that don't know what commit is, we're going to get into that. But essentially, one of the large parts of DevOps is working together, and that means that we all want to be looking at the same code. And so we use version history and commit history. So you have Git, which is a version control software. You install it. It's very lightweight, and it essentially takes a snapshot of all of the files you're working on every time you tell it to. And anytime you make some changes or work on a particular thing, you would take another snapshot, and that way you have multiple places throughout the life cycle of the application that you're writing where you can roll back to or integrate, that feature into the main trunk once that feature is all the way done. And so the main branch can continue to live on without any interruptions while you're working on a particular thing. And then once you're ready to bring it in, then you do what's called a merge. And I can get into that in a GitHub, in a Git video. I will do that at some point. Just wanted to put that out there for now. So back to, so we have testing, monitoring. We want to look at the performance. And again, there's Slack comes back here. There's App Dynamics, Splunk, New Relic. There are all kinds of them that do this stuff, but we want to be looking at the performance of our server and the performance of our application, and try to head off any problems that we see possibly arising here. And continuous feedback. Now, continuous feedback is kind of a combination of things, right? So after you've launched your application, then you would be getting user feedback, right? And you would be, users would obviously be finding bugs, and you would want to collate all of that information, right? You collect it and review it, and churn out surveys, bug reports, support tickets, and even tweets, right? And we want to be analyzing and incorporating that feedback as fast as possible. It's usually a slow, it's a slow process oftentimes to get that feedback integrated in our development. But the more efficient in the long run you are at doing that, the faster you will be able to fix those bugs and get those new features out that everybody is wanting. So this has been a more in-depth look at what DevOps is. I've given you guys some specific examples of what sorts of applications are involved with DevOps, and I hope that this has been helpful for you guys. If it has been, please give a like and subscribe, hit the thumbs up, hit the notification bell, and you will be notified of the next video release. Check out my other content. Head to my website, consultingninja.tech, where I have put together a list of resources by category, all free stuff for you guys that will help you out in your journey. And stay tuned for the next video. Leave a comment as to what you guys want me to do next, and I would be happy to get into it. Have a great day.